All right, guys and gals, we are ready for section 13 notes, solving with sine, cosine, and tangent. You want to make sure that you have your calculator ready that has sine, cosine, and tangent on it, and we are ready to begin. So, solving with sine, cosine, and tangent. We've already established our mnemonic device, SOHCAHTOA. We're going to use that today. And before we begin, I want just to remind you that all right triangles with a 20-degree angle are similar according to the angle-angle shortcut. And this means that all side lengths with a 20-degree angle are proportional. And we're going to use that today to solve for missing sides. So we're going to write an equation that's true to solve. Okay, and that's why we were able to find these missing side lengths and use that to our advantage. So what we're going to do is we're going to use these diagrams and find the missing value. So let's go ahead and get started. So what we have here on A is a 52-degree angle, this side length of 15 and this side length of x. Your first step is to realize, okay, I'm going to use this 52-degree angle right here. What is the relationship of x? Well, x is the hypotenuse, okay? And 15 from 52 is opposite. So now you ask yourself, which trig function uses the opposite side in the hypotenuse? Sine, okay? And that comes from the SOHCAHTOA, S-O-H. So we're going to use sine. So what we know here is that the sine of 52 must equal opposite divided by hypotenuse, which is 15 over x. So we know this is true. So our job is to solve for x. X is in the denominator right here. Okay, we need to get x by itself. So this is a three-step process that I'm going to show you, and then I'll show you how we can kind of rearrange in a shortcut kind of method. But what we're going to do is we're going to multiply both sides by x. Okay, so we get rid of the x over here, and we're left with then x times the sine of 52 equals 15. And again, we want to get x by itself, so now we need to divide by this sine of 52. Every time you set up an equation, x is either going to be in the numerator or the denominator. And this is the math that kind of goes along with when the x is in the denominator. So this is what we have right now. We have that x equals 15 divided by the sine of 52 degrees. That's what we're going to type in our calculator. 15 divided by the sine of 52. Remember, on the graphing calculators, you want to make sure that you are in degree mode, not in radians. So to check that, you go to mode and make sure that degree is selected. I'll show you one more time. Click mode, and then you arrow down and make sure you're on degree. And then you can hit second mode to quit out of that screen. So we need 15 divided by the sine of 52. And so we're going to round to the nearest tenth on these side lengths. So in your calculator, you should be getting 19.035, and that's going to be 19.0. Now we want to keep that. We want to keep that as 19.0 so that the viewer knows that you had to round and it wasn't exactly 19. Okay, so when you get a decimal answer and you're told to round to the nearest tenth, keep that 0.0 on there. Okay? So let me just take a couple more seconds here and talk about this. Let's think about what we had to start with. We had sine of 52 equals x, or excuse me, equals 15 over x, and this is what we typed into our calculator. Okay, so what's the correlation here? Okay, something that I will share with my students is when x is in the bottom, you can swap them. When x is in the bottom, you can swap them. So when you see sine of 52 equals x over 15 over x, I do want you to write this out. You could just draw an arrow and say x equals 15 divided by the sine of 52. Okay, now some of you are going to be trying to find these answers without writing everything down. Well, I can't give you any partial credit or help if you don't write and show your work. Okay, so make sure you at least write down what you're typing into your calculator so I know what you're dividing. And we're not always going to divide. Okay, this is what happens when x is in the denominator. So let's go on to example B here. So we have here that this angle is 37 degrees. We want to know the relationship of the x and the 14. So I always label the hypotenuse first. It's always across from the right angle. And what is x's relationship to 37? X is now the adjacent. Good. And so which trig function uses the adjacent and the hypotenuse? Cosine. So cosine of 37 must equal x over 14. Adjacent divided by hypotenuse. Now this goes a little bit faster. When this coefficient here, or this 14 is in the denominator, I only have to do one step to get x by itself. The opposite of divide by 14 is multiply. Multiply both sides by 14. It cancels. This is what you type into your calculator. Okay, 14 times the cosine of 37. Now sometimes you might see me put this in parentheses, this angle. It's kind of a clear way to show that 37 is the angle that you're typing in. And also when you're using your calculator, so it's 14 times the cosine of 37. Notice what happens. Your calculator opens that parenthesis. Okay? You don't have to close the parenthesis because you're not typing anything else in that instance there. So the 14 times the cosine of 37 is 11.18. So this 8 is going to turn that 1 into a 2, obviously, when we're rounding to the nearest tenth. So our answer here is 11.2. Do we have any questions now that we've seen those two examples, A and B? All right, let's take a look at C. So again, from angle C here, we have this 24 degrees. We want to label. We know, and sometimes I go ahead and I write the H here for the hypotenuse, even just so I know that I'm not getting it messed up, okay? And then 8 from 24 is my opposite, and X is my adjacent. So which trig function uses O and A? Tangent for TOA. So we know that we're going to have the tangent function now. Tangent of 24 must equal O over A, 8 over X. Bless you. And again, when the variable's in the bottom, we can swap them, knowing that work that we did earlier of multiplying both sides by X, divide both sides by tangent of 24. This is what we're typing into our calculator. 8 divided by the tangent of 24. And again, when you type in 8 divided by tangent of 24, we're getting a value that ends in 0, but we want to go ahead and keep that 18.0. But go ahead and type it in your calculator and make sure that you get that. Well, actually, excuse me, we're getting 17.96. So it rounds up to 18.0 on this one. So 17.96 rounds up to 18.0, but again, keep that 0.0 so your reader of your answer knows that you had to round. So we have a couple more examples to go through here. What's a little bit different on example A is that we now have 2 missing sides. Okay, so it doesn't matter which one we solve first. A lot of students just usually solve for x first. So let's go ahead and find that relationship. So from that 36 degrees, hopefully you would agree that 10 is your hypotenuse and x is the opposite. So which trig function uses O and H? Sine. So the sine of 36 equals x divided by 10. And to get x by itself, you multiply that 10 over to the other side. So we know what we're typing into our calculator is 10 times the sine of 36. I got 5.9. Do you guys agree? Okay. And then to solve for cosine, I'm still using this 36 degrees, but now y is my adjacent. I'm still going to use the 10, the hypotenuse here. So adjacent and hypotenuse, I need to use cosine of 36. So cosine of 36 equals y over 10 this time. So in your calculator now, y is going to equal, again, 10's in the denominator, multiply it on both sides. So we're going to multiply 10 times the cosine of 36. So each time you solve, you're either going to be multiplying or dividing. Okay? So go ahead and type that into your calculator to figure out what the value of y is. Does 8.1 sound good? All right. So let's label B together here. If I'm going to solve this, I know that 8 is my hypotenuse. Y from 64 is the opposite, and x is the adjacent. So I'd like you to take a couple minutes here and solve for x and y on example B and C. Alright, so if you are not done with B and C, you could hit pause on your video. Otherwise, we can go ahead and see how we're doing here on B and C. So first of all, to solve for x, I used cosine. Cosine's your adjacent and hypotenuse. So I have cosine of 64 equals x over 8. And to get x by itself, I'd multiply both sides by 8. So in my calculator, I'm going to type 8 times the cosine of 64. And you should get x as 3.5 rounded to the nearest tenth. Then for for y, I used sine. So the sine of 64 equaled y over 8. Again, multiplying both sides by y. And so we're going to have y equals 8 times the sine of 64. That's what you type in your calculator. And my answer is 7.2 rounded to the nearest tenth. On C, from the right angle, hypotenuse H is side Y here. From 37 then, 18 is my opposite and X is the adjacent side. To solve for X, I'm using tangent. So you can't put Y and X together in the same equation, so we will not, if you look, sometimes it's nice to look and say, hey, I will not use cosine because cosine would use X and Y. So we know that to solve, we're going to use tangent and sine. So I'll use tangent to solve for X. Tangent of 37 equals 18 over X. And when the variable's in the bottom, I'm going to swap them. So I'm going to have x equals 18 divided by the tangent of 37. Now when you type that in your calculator, we are going to get 23.9. The number after 9 is not 5 or bigger, so we're going to leave it 23.9. To solve for y, we're going to use sine, and it's going to be sine of 37 equals 18 over y. Again, with the variables in the bottom, we're going to swap them and divide. So in your calculator, you're going to have 18 divided by the sine of 37. And again, we are not going to round up this 29. It's going to be 29.9. For 18 divided by the sine of 37. So you're getting 29.909, and so that 0 after the first 9 is going to leave this 29.9. Okay, so we do have one more example here. So we want to draw a picture to go along with this. Your dad is building a ramp for your front porch for the uncle who's bound to a wheelchair, and your porch is 3 foot off the ground. And your dad wants to have an angle of 20 degrees, so it's not too steep. So we have these stairs, okay, that are here. The stairs are coming off the porch. You want a ramp that's probably not wobbly like I just drew. All right, so imagine that this is a flat line here. All right, so this was where the stairs were in this vicinity, and this is the ramp that we want to have. We want that ramp to be at a 20-degree angle, okay? So it's going to be pretty long and flat. And that porch, that front door, the top of the stairs here, they said that was 3 feet from the ground. And we want to know how long is this ramp going to be. So this is the mystery length here. So from 20 degrees, 3 would be my opposite side, and x would be my hypotenuse. So which trig function uses opposite and hypotenuse? Sine. Opposite and hypotenuse is sine. So we know that we're going to have the sine of 20 is equal to 3 over x. So then to solve, what you would type into your calculator, 3 divided by the sine of 20. So we know that this ramp is going to be 8.7 feet, 77, so it's going to be 8.8 if we round to the nearest tenth. Okay, so that concludes section 13 notes.